Okay. So we're going to start with what a combination is. A combination is how many ways something can be chosen when order doesn't matter. So let's say I was talking about the lottery, and I said that you have to get 6 numbers correct, but they don't have to be in order. Okay, so like you have to pick the right 6 numbers for the lottery, but you don't have to be in order. How more likely do you think that's more likely or less likely than getting them in order? More likely. Does everybody agree? That if you just have to just get the numbers, they don't have to be in order, you just have to get the numbers, that it's easier? Okay, that's called a combination, and it is a lot less. So let's try it on our calculators. Go grab your calculator if you don't have one.
I got you.
This formula so far is exactly the same as the permutation formula, that n factorial on top, the bottom is n minus r factorial, but then you also divide by r factorial, which is taking away the order of things. So this part is the only difference, and that is taking away the order of things. That equals n choose r, where n is your total choices, total possibilities, I guess. And R is how many you are choosing. Okay, so let's talk about the lottery. Let's say that there are, anybody play a big lottery game before? No? Okay, let's say that there are 36 options for the little balls that come up, okay? I don't know, I think that's about right, probably in the 30s. I don't think they go up, do they go up to like the 70s and stuff like that? Does anybody know? That'd be really impossible, but the lottery is supposed to be impossible, right? That's how they make their money. Does everybody understand that the lottery and casinos are an excellent business? Like, excellent business. I mean, they make, like if somebody wins the lottery, they lose millions of dollars, right? But selling lottery tickets, they make so much more. I mean, that's why they are that business, because people buy those things. So let's say that you just had to get it, just get this, the 6 numbers exactly in order, and there were 36 numbers. So I'm going to write 36. There are 36 numbers to choose from, and you have to get them in order. So we're going to go to math, and then over to probability. Which one is the one that puts them in order? Order matters. That's a P, which is permutation. Combination is the one where orders don't matter. That's the one that we just did, okay? So permutation is the one that order matters. We're choosing 6 numbers. So there are 36 numbers to choose from, and we're choosing 6, and they have to be in order. Okay. That's your chances. That's how many options there are. 1,402,102, or 410,240. Now, if I just divide those two, if I'm just like, okay, well, let's say there's 1 lottery ticket. So, okay, so your chances of winning the lottery are, should we go in a percentage? You want to do a percentage? Okay, so 0.8 zeros and then a 7 are your chances, percent, are your chances of winning the lottery. It's only 1 in a billion. Well, not true. 1 in 1.4 billion. Okay? So If you're interested in playing the lottery, may I make a suggestion to you? If you're gonna spend $5 on the lottery, take your $5 and then give it to me, and then I will also not give you any money. Okay, like it's the same deal. You don't have to go to Quick Trip even. Like you can just give me $5 and I will also not let you win. Unless you happen to be the one in a billion. But that's not to say that there aren't some games or some risk games, some gambling games that actually are pretty close to fair. Do you guys know what gambling game at a casino is the most likely that you would win just on chance, not on skill? No, definitely not. Roulette, exactly. So roulette is that one where you spin the wheel and like that little ball bounces all over. And if you bet on black or red, half the spots are red, half the spots are black, except there's one spot that's a 00 that is neither red nor black. And that's why the odds of the casino will never, ever, ever have a game that is exactly fair or in your favor. But this one is slightly, just like, it's like your odds of winning are like 0.48, which is still good for them, right? Because it's less than 50-50, but pretty close for you. Definitely better than 48% is definitely better than 0.0000008%. Okay? So, or if you have skill, or if you can count cards, go to that casino. You know, if you can play a card game and you have skill with it, excellent news. You can make a career out of that if you want to. But if you are playing slot machines or buying a lottery ticket, if you're buying a lottery ticket, I highly suggest you look at the runner-up prizes and decide that way, because you're not going to win the billions of dollars. You're not. Could you win $1,000? Actually, maybe. Right? Has anybody known somebody who's won in the lottery? Like $100? Like a small amount? Your mom won $2 once. How much she spend?
$2.
Okay. And if you would like a lucrative career, may I suggest working for the lotto? It's nice. Okay, oh, back to this. So, this was if they're in order, right? So now let's try again. Let's try not in order. Go 36 first, and then math and CR this time. This is a combination. You just have to get the 6 numbers right. They don't have to be in order. Oh man, that almost looks pleasant. A chance in 1.9 million, that's all? So, I mean, if they don't have to be in order, do you see how this is much better odds for you than that is? Okay, and that's where this comes in. It divides out some of those options. All right, so I'm going to try example 6 with you, and then you're going to try example 7 with your partner. I do have a special prize up here today, which I will also do a different day so that you don't only have one chance to do it if you want to. But these right here are something that you cannot take. Have I shown this to you before? These are my senior pictures from high school.